All right, let's do a rotation from this as the rotation point and rotating these 2 points. So we could actually just do one, but we'll see. Okay, so this becomes your 0, 0, and this becomes your rotational point. So you have to find out how far everything is from here. So rotation point wise, this is going to be 5, 1 away from this point right here. Okay, now if this is the center, it's got to rotate, which means these numbers have to swap, okay, and yeah, they have to swap. So now they're going to be 1, 5 from that point. So now if this rotates, let me see here, let me show you what I mean. So if this is -2, 1, so that's right here. And now that one is 3, 2. Okay, so the distance from here, -2, oh, it's just 3. Sorry. So 1, 2, 3, and 2. So that distance here, okay, 5, 2, now has to be 5, 2, meaning it's going to end up right there. Okay, so it's got to go down 5 and to the right 2. So down 5 from here, so down 5 and to the right 2. Oh, sorry. Man, I keep on messing up, guys. Down 5 and to the right 2. This is going to end us at 0, -4. Okay? So you find out the distance, okay? And then you swap the difference. So it goes, hopefully that makes sense, right? So we're still rotating here, but then you just have to figure out what it did to get there and then watch it rotate and make a new L. Okay? So you're kind of looking at this triangle here, and then you're rotating it, so then it makes that triangle there. Kind of making like a little windmill if you keep on rotating it. All right, so then the next point would be 1, 7. How far is 1, 7 from there? So that's up 3 and then up 6, right? So the first point is at -2, 1 right here. And then 3, 6, so 1, 2, 3, actually 1, 7, 2, 3, 4, 5, 6, 7. That's going to be here. So this is going to the right 3 and up 6, making this triangle. Right 3, up 6. So now it's going to go down 3 to the right 6, making this new triangle. So this is going to be, so if I go from here and if I go down 3 and to the right 6, okay, I'm going to end up at 4, -2, our new location. That's how you rotate points from an odd center, okay? Next, we're going to be talking about the different types of way of proving two triangles are congruent. There's side, 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 which means all the sides are the same. Sides of two triangles. So side, angle, side means that there are two triangles. They share two sides. Not only do they share two sides, they share the angle that is in between the two sides that they share. So it can't be this angle and that angle. Okay? It would have to be, let's erase this angle and that angle, so that the two sides they have in common and the angle in between. Now, very similar is angle, side, angle. So they have to have two angles in common. So these two triangles have two angles in common. To be proven to be congruent, they also have to have the side that is in between them to be the same. And that's angle, side, angle. Now, angle, angle, side, very similar. Okay? Angle, angle, side. means they have to have two angles in common, okay? And the side has to be in common as well. Now, it has to be a specific side. It has to be the side touching the second angle. And not, see how this side is touching that angle, but is not touching this one? It's very specific, because some people can think that this is angle side, and it is not, because this side is touching that angle, okay? And the side should be touching that angle. Very specific. So you should be able to be like angle 1, angle 2, side. Angle, side. Here it's angle 2, angle 1, side. Doesn't work out, okay? All right. And hypotenuse leg theorem only works on right triangles. Only works on right triangles. So if this is a right triangle and there's another right triangle, okay? If they have two sides in common, 3, 5, 3, 5, that is enough to prove that the triangle is congruent. You don't need anything else, okay? Because Pythagorean theorem would define this one as 4 and would define that one as 4. So it 100% makes it side, 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 just knowing two sides of the right triangle are the same. It's called the hypotenuse leg theorem. Okay, next, a couple of vocabularies. So when you find perpendicular bisectors, which means you find the bisector and go perpendicularly up. You see how it's not going exactly to the corners? So you find the bisector of the side and you go perpendicularly up. What you're finding is the circumcenter, the center, okay, of all the vertices. So all the vertices are equidistant from there. So that's why I can make a circle around it. The next one is angle bisectors. So angle bisectors find the center of the circle inside of the triangle, okay? The incenter, okay? Because this is an inscribed circle. So the incenter, that means at that point is equidistant from all of the sides of the triangle, okay? Whoop, that was horrible. There we go. All right, next one is an altitude. Altitude, another word for altitude is height, and the height of the triangle going here, and then if you turn the triangle, the height going there, and then that triangle height going there will cross at this point. Okay, this point, depending on where it is, will tell you if it is acute, obtuse, or right. Acute will be inside, obtuse would have ended up outside, and a right triangle would have ended up right in this corner. Okay, all right, next one is median. Okay, the median, which is coming from the angle and cutting the side in half. Okay, coming from the angle, cutting the side in half, is called the centroid. It cuts every single portion into a 1/3, 2/3 portion. So if this is 4, this would have to be 8. Okay? If this is 10, this one would have to be 5. Okay? Like that. So it's a pretty simple idea. You can watch the video on those main topics. Now, there are two. Now, surface area is a very simple, basic idea. It's just the area of all the surfaces. But there are 2 shapes or 3 shapes that are slightly complicated. Now, the first one is the cylinder. The cylinder, now the volume of this is very easy. It's just area of the base times the height. So pi r squared times height. Very easy. The surface area isn't. First, the surface of 2 circles. So 2 pi r squared. Okay? Which means 2 circles. That's easy. It's this center spot that throws people. Now the diameter, you're gonna need the circumference of the circle because what this opens up to is a rectangle. So you're going to do the area of the rectangle in the center is diameter pi times the height. Okay, and that's the area of the rectangle. And that's it. Okay, so that's the surface area of a cylinder. The surface area of a cone, oh, that was horrible. Surface area of a cone, okay, first there's 1 circle, so you start with pi r squared, and then you have to add that to the other shape, which is that top part of the cone. The formula for that is pi r l. okay? When you open it up, it's like part of a circle. How much of the circle is represented by the slant height? So it's pi r L, not pi r squared. So that's the two portions for this one. A sphere is the easiest one, okay? It's just, so you're definitely going to use the circle formula, but how many circles does it take? How many center circles does it take to encompass this sphere? 4 of them. And those are the surface area of the odd shapes. Surface area of regular shapes would just have triangles, rectangles, and squares in it, or trapezoids, and you know how to find the area of all those. So you just find the area of all the faces and then add them up. These are the only odd ones. And that's it.